like look no further, look no further. Look no further. It goes like look no further. Look no further. It goes like I never thought I'd find it. A love that feels so perfect. I can't even word it. Yeah, you make me lift up from the ground. I believe that we are more. All the world is looking for. Show them all we got it. Never look back, never let go. I don't need to look no further. You are the one I'm certain. Only one that I'll be holding. When you're loving me, you're loving me. It goes like look no further, look no further. Look no further. It goes like look no further, look no further. Look no further. It goes like I believe that we are more. All the world is looking for. Show them all we got it. Never look back, never let go. I don't need to look no further. You are the one I'm certain. Only one that I'll be holding. When you're loving me, you're loving me. It goes like look no further, look no further. Look no further. It goes like
I wish I could tell you that I want you here with me, but you'll never love me like the way we used to be. Too far from Saturn, close to the patterns. Where's the stars align so we could be free? Palms are sweaty, knees unsteady. I can't see my head on straight. Heart is heavy, wasn't ready. Don't think I can see your face. Now we're just friends. How long till that ends? It feels like forever away.
Oh, I don't mind a little rain on my suit. A little bit of angry makes you cute. And we've been watching this show so long, but it feels like everything that we wrote went back into the pen we used. It won't take long, even when I'm without you, when I'm without you, babe. So listen up and play along. And that's how time flies, like we on a different timeline. Tell me that you're here and feeling down for anything. Oh, I'm down for anything. This fine line that we keep on walking all night. Tell me that you're here and feeling down for anything. Oh, I'm down for anything. Down, 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 if we can keep it. Down, 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 if we can keep it. Down, down, down. Oh, I'm down for anything. Down, 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 if we can keep it. Down, 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 if we can keep it. Down, down, down. Ooh, I'm down for anything. Yeah, we can make a mess inside this booth. You're taking me to places old and new. Sweetest sound than our favorite song. And it feels like every time that it comes on, we just roll on till the day's done and the lights gone. And it won't take long, even when I'm without you, when I'm without you, babe. So listen up and play along, yeah. And that's how time flies, like we on a different timeline. Tell me that you're here and feeling down for anything. Oh, I'm down for anything. This fine line that we keep on walking all night. Tell me that you're here and feeling down for anything. Oh, I'm down for anything. Down, 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 if we can keep it. Down, 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 if we can keep it. Down, down, down. Oh, I'm down for anything. Down, 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 if we can keep it. Down, 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 if we can keep it. Down, down, down. Oh, I'm down for anything. For anything. For anything.
I keep dreaming, but my dreams keep flying away. It's somewhere far beyond. Keep chasing them and I never rest for a day. There's something I don't do. I feel the wind blowing my face, but that's alright. I smile at people passing by. Some smile back, some might not. I'm always looking for a shade when it's hot. I've been low key and I'm trying to stop. God, I'm feeling good. Yeah, but when off I go. Pretty afternoon, it's a fast forward. Looking at the skyline, looking back at my life, and I gotta say it's one of a kind. Yeah, but when off I go. Pretty afternoon, it's a fast forward. Looking at the skyline, looking back at my life, and I gotta say it's one of a kind. It's been a while since I ran into you on the street. I wonder if you moved. Hope everything is going amazing for you, and you're not feeling blue. I feel the rain pour down my face, but that's alright. I smile at people passing by. Some smile back, some might not. I'm always looking for a shade when it's hot. I've been low key and I'm trying to stop. God, I'm feeling good. Yeah, but when off I go. Pretty afternoon, it's a fast forward. Looking at the skyline, looking back at my life, and I gotta say it's one of a kind. Yeah, but when off I go. Pretty afternoon, it's a fast forward. Looking at the skyline, looking back at my life, and I gotta say it's one of a kind. I slip to the bind it to the blue. I slip to the bind it to the I slip to the bind it to the I slip to the God, I'm feeling good. Yeah, but when off I go. Pretty afternoon, it's a fast
Hello, 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 welcome on in. I'm only Benzo and Hans, we have Hans. Hi, hi. How's everyone doing today? Hi Panda, hi, come on, welcome on in. I'm just readjusting myself. Okay, I will actually start off with saying I was going for full model today. Like, here's me, it's regular old me, and here's me. Actually, stand it up just a tad. There you go, you can see a little more of me. I will actually say that the fishnet almost went on, but I just wasn't certain I would be able to do that and keep it safe. So, yeah, we kind of lost the fishnet. Okay, we'll go down a little bit. But, as you can see, I did have them here. So, like, you almost got fishnets, but yeah, I was just like, am I going to be able to do this on screen and not completely messed up? Possibly not. So, that was the decision for that. Oh god. So, we are here today because I was looking at doing stuff with electronics happening for a while, but it turns out I can't remember anything. Hey, lad. How are you doing? Thank you for the Tom 5. Goodbye. Goodbye. How are you doing, lad? Wait, which way is it? That way. Look. Look at the 5s. Look at them. Where? That way. Yeah, look at the 5s. Oh god, that clip is so amazing. Like, your clip of that is amazing, but like, I mean the original clip.
She has nice hands. Yes, she does.
Yes, she does. Now I go with the 5s, with the 5s. By the way, Twitch, here's some safety shorts in the LC. You can see the line, safety shorts. This is what I mean about, like, I didn't trust myself with just having the fishnets on. I've got layers upon layers upon layers. So if you see anything, you're seeing another layer. Because I literally didn't trust myself, because I will actually say, this is kind of short. You can't see much. Maybe I'll stand up a bit. There's the top to the bottom. It's kind of short, so like, I don't trust myself sitting here. And, not showing something. I decided to go like full model, so we've got the top, we've got the body, which, to be fair, I will actually say this is based on my comfort first. See, if I didn't have safety shorts on, that would have been very risky to do. And I just did it instinctively and went, ooh. Oh yeah, when I say it, like, I designed this one literally on me. It was. Also, the music's a bit loud. Oh god, why are you so loud? It should be like background music. I don't know why that... I haven't even touched the music, so why is the music... Okay, never mind. Well, I guess we can start with the show and tell part of today. Yay! As you might notice, we've got things all over the screen. Because, well, I just picked out the electronic starter kit that I had from years ago and thought, since I can't remember much of like anything, why not do this? It's an Arduino clone. I do have the Uno variant here, which I guess is technically upside down. Just a little breadboard. The cable's can attach to the computer, but each of these, I don't know whether you can see them. I might need to manually refocus this a bit closer. There you go. Each of these little ports along the edge is for a cable to go in. And they each do different things. You probably won't be able to read them. If I hold it really close, can you? Maybe if I could hold it a bit steadier and there you go, you've got numbers on them. 8, 9, 10, 11, 12, 13. The other side you have 5 volt, 3.3 volt, ground, and I have no idea what the last one is. Too blurry. Oh, V in. Voltage in. On the other side, down there, you have the analog pins, and basically what all this board is actually, I'll hold it up. This long chip in the middle is basically a programmable chip. I should have left autofocus on, it's just annoying because it keeps trying to refocus. So I'm having to do it manually. But yeah, this chip down the middle is actually a reprogrammable chip. That's what the cable is for. Basically, as you can see down the bottom of the screen, this one, we can write a computer program to upload onto the board and it will do whatever program. That's what we're going to be doing today. Because the kits that I do have here has a load of different electronics components in it. If I can do this, we got little things here like a little joystick. You can hook that up and get all the inputs from it, use that for controlling things. 4-digit display. Yeah, it might do something with that. But yeah, got all sorts of things here. Like I've got a keypad, which that's 8 connections into it, but digital keypad. So like loads of different things can do today. What I was thinking is I might follow along with some of what they're doing and then possibly later on just try and wing it and go, well, we've got these components, we've got different things, why not just see if we can knock something together. This board here is actually the larger variant. Actually, I'm going to refocus that on just the desktop. There we go. I'm just going to pop over that one. That has a lot. Oh my god, you're all really jammed in that. That is the larger variant. Basically, this does exactly the same. It's just a little tiny thing in comparison. This is a nano variant. It doesn't have as much of the development features on, but it has almost all the same pins out. They just needed to be soldered in. I actually had to solder in the pins for that myself. But you could just connect wires up to only the ones that you actually use. This one I would definitely use for more development purposes because it's very easy to just stick things in, keep doing and test things out. But if I actually wanted to use it in the wild, so to speak, I would probably use this one because you can program it the same. It has most of the same outputs, well, input outputs, but that uses a hell of a lot less power because this one has to power a load of things on the board itself, whereas this one only has
need more head pats on each hand.
Thank you for that, Pat. What you doing? We're doing electronics because it's been years since I've done any and I can't remember how to do much of it. This I'm sticking this back in is literally just to protect the pins in this case. It is a breadboard. Basically, each of these lines going across are connected. So if you want to connect two wires together, rather than having to connect two wires, I can take a wire, I can put in a hole. I can take a different wire and put in a hole in the same line. There's too many wires there, but yeah, they're in the same line, so them wires are now connected. Breadboards are absolutely amazing things because it just means you can do prototypes, put it together, take it apart. You show me how to build you. See, that's the thing though, like you could very easily go online and find instructions for doing so. The hard part is getting the materials. Like, I've seen it said before, and I do believe it to be quite true. But basically, if you go to any scientist advanced enough, they could actually do that. Because it's very actual simple scientifically. But actually getting the stuff to do it, it's a little more complicated. By a little, I mean a hell of a lot. Oh yeah, there's this little thing. This is basically a radio frequency chip. It's a little keychain with a button on it that connects to that. Basically, it just activates if you press the button. That's all it's for, but that's actually pretty cool because you could make whatever react to you pressing the button away from it. So, I don't know what's actually in this Getting Started manual, so you're going to be learning as I go along. No, it's a stream where I can learn something or where I can feel extremely stupid. Don't worry, I will be feeling extremely stupid all the way along doing this because I used to actually do like little bits of this as a hobby, but it was years ago. Now I can't remember anything. Also, welcome on in. This one's a fun one. The LCD 1602 module with pin header, one piece. I do actually have that connected to a board here. It is basically just a little LCD display that you can type text on, numbers, whatever. Last time I actually used this, I made a little temperature readout for my room, because somewhere in all of these things, we'll have to occasionally pop back and grab things. I think it was this little setup that I had was basically hooked up to, that's what the wiring's for, to connect to this screen. The pinout will match somewhere on it with them. Way around, possibly. Yeah, that makes more sense. But it would basically get the temperature from this blue sensor. I believe that's temperature. Don't quote me on that though, because I might be misremembering. I don't know what all the components are off the top of my head. But yeah, it would just read the temperature. It would format it into a format that you could display as text on the screen and show it. Might have a go at remaking that if I have time tonight, and if I actually learn enough of the process to do it again. Always look fun for me as a mechanics sucker for electronics and tech. Honestly, yeah, I would say there's some definite good go-betweens. I know I have one of the components here somewhere. Is it you? Don't think. I think it might be you. This is a good go-between. I believe, if I've got the right one, this is a stepper motor. So rather than a motor that just you apply power and turn, it's a motor that turns a specific amount every time you give it a signal. It does mean you can do stuff accurately, but now you're going from the electronics into the mechanical side, and it's things like this stepper motors that allow you to do a lot of the robotics, because you can control the precise built-in encoder. I don't know, probably. I have no idea. Never actually particularly used that. Okay, I'll see if I can find in the list, see if this describes what that one is. It is possible it wasn't from this pack, unfortunately. Buttons for the LEDs. It might have been from this pack, that one, but this pack did have some stepper motors in. Yeah, it had one of them. Actually, that might be the same one. Yeah, it is the same one, it's just not showing the other chip. The other board is part of that. I assume the board is listed elsewhere. There's a head down picture that is definitely the same as the head down picture of out of the manual. So it might be listed as a separate. Servo motors, they're also good ones for controlling. Are you listed the other board here? I would expect the board is listed because it is a piece of the kit, but whether or not they've just went, that's not important. I know that definitely came with that, it wasn't separate, but it does not look like it's actually listed, which is unusual. Module. Oh, there we go. Found it. ULN 2003 stepper motor driver module. Did you purchase like a combined package? Yes, this one is a combined package. I got it, God knows how many years ago at this time. Elegoo, the most complete start kit tutorial for Uno. It's basically based on the Arduino Uno design, just different manufacturer. That's this board, the Uno. I also have quite a few Nanos. The Uno is definitely more of a development board. The Nano is definitely harder to work with because it doesn't have anything really. I've soldered in the standoffs. Actually, do I have one without these standoffs? Probably. I know I've got a little box here. I do have one that's I don't have it here. Unfortunately, I think all the ones I've got might have the standoffs put in. But yeah, it's just a bare board and you can solder on the different wires you want for whatever. But it has a lot less on the board to actually run, so it runs at a ridiculously low amount of power. Technically, you don't actually need most of this board for it. You could wire things directly into the chip and run the chip, but then you're going into a whole different level of doing it. Right, so what have I got there? Okay, I'm just looking and going, why is the back of that one pulled off and have the power strips exposed? It's just two metal bars running down the back because you've got the negative and the positive power that you can run along the edge of each board. There's anything in that. One wire, so I'm just going to pop that. So these breadboards do actually just slot together. They've got little guides to fit together. So if one's not enough, you can use two. Chuck that over there somewhere. So, we've got loads of things through here. Ultrasonic scanner. I know I've got that here somewhere. Unfortunately, there's not much to actually show visually with that because all it does is emit an ultrasonic sound, bounces off things and comes back. And basically all that will return is the time it took for, which you can use quite well, like especially just using it with, say, step and water and just turning it and going, well, how far away was each object at each position, and you can make a map. And that's how ultrasonic mapping basically works. You've got the one point in the middle that is a known location. You scan round and go, how far away was it to each of the objects? Okay, I've got a map from this location. Then you move that and you do it again. And now you've got 2 points of reference and you can go, well, this line from this point went that far, this line from this point went that far, and then you just start to be able to triangulate the edge of objects and everything like that. Right. Where does this actually get into something rather than listing? Okay, installing the IDE. I have done that. I think libraries not able to serial monitor. Hopefully I did that. Okay, I've installed the Arduino software and the stuff. That is the window we have down the bottom here. We'll actually just take that Arduino, unlock that. As you can see, actually you can't because it doesn't actually capture the top bar, but this is the Arduino IDE, Integrated Development Environment. So I can select board Arduino Uno on COM3, which is communication port 3. Why is it free? I have absolutely no idea. I just plugged in a USB and it worked. Right. Pick up. Don't know why once TTS came up there, but okay, drivers. Luckily, the new installer installed the drivers automatically. Okay. Include libraries. Use the library manager to install a new library. Oh, I've done this before, I remember, and I was looking at this earlier today. Oh god. I remember now. Yeah, because I was looking and thinking, okay, I'm just going to... Oh, you're further down. Right. Move you up there for a second. Share the screen. Sorry for the infinite. I'm going to here. I was looking at these before because, well, you've got the library managers, so you've got different libraries you can use. Easy library support to make an Arduino IRC board. Also supports Twitch chat. I was just going, ooh. Twitch API. A library to wrap the Twitch API. A library. Yeah, there. Okay, so I'm actually interested in looking at that because I've been thinking about this slightly and going, I know it should be easy or easy enough to actually integrate this into chat side stuff and make it, actually, ideally, I would love to make something that, well, either responded to like things happening on stream or could be triggered directly by people on stream. I just realised I've left the library window open. How do I... that's how I close libraries. Nope. Okay, just double click on it. Fair enough. Open. Dun, dun, dun. Okay, so I might need to do that and import some libraries. I don't know in this version how to import them from a file. That's boards and sketchbooks. Debugging is not supported. Brilliant. Okay, so I might run into some issues if I need to load this from a file, because I do not know how to. Basically, the version of this that was included with the help file is no longer used. So I will either have to go find the old version of this, or I will need to wing it and hope it works. Okay, there's actually a manual installation, so that could possibly work. Oop. Okay. Right, so we're supposed to be looking at examples, basic, and we're going to look at Blink. Which isn't going to capture because it's different. Okay. There we go. Blink turns an LED on for 1 second, then off 1 second repeatedly. Most Arduinos have an onboard LED you can control. On the Uno, Mega and Zero is attached to digital pin 13. LED built in is set with the correct LED pin independent of what board is used. Okay, so Right. I'll need to move this ever so slightly so you'll be able to see. Right. Okay, there's two basic functions that get run on the Arduino. Anything that's in setup function is things that run once when it turns on. So basically, initialize digital pin, the LED built in, as in the built-in LED, as an output. So set that as an output. While it's running, everything in the loop gets repeated. What this is doing is it's writing to LED built in high voltage, because basically on the digital it's just going to go high voltage, low voltage, high voltage, low voltage, because I don't know if I've got anything with it. Digital voltage, you know what, that'll do. I did not copy the link for that. Copy image address. This is basically what digital signal does. It's at a high voltage, it's at a low. And that's basically all a digital. It's the equivalent of a 0 and a 1 in a digital signal. It's either off or it's on. It still has a voltage, so it can be clarified differently from disconnected, but it has very distinct two different levels for 1 and 0. And that's basically what this code is doing. It's going digital write, which is writing to something. LED built in is the light, and then high is for the high voltage, which is going to be turning it on. And then delay 1000 is wait 1000 milliseconds, so 1 second. So wait a second, and then it's going to digital write to the LED low, which turns it off. Then it'll wait another second and loop back to the beginning. So basically what all it's going to happen is it's going to turn on, wait a second, turn off, wait a second, and then repeat. So this is a lot of what we're going to be doing to begin with, just learning how this works. Hi there! Hi! Right, now how do I do this? Sketch, verify and compile, which hopefully compiles since it's one of their examples. It does. And then sketch, upload. Now watch the orange button, the orange LED. On, off, on, off, on, off. Yippee, we've managed to make a blinking light. But now that we've got the code for this, we can basically change this bit. Like if I change this to be 250 and 250. Now it will every quarter of a second turn on, then after a quarter of a second turn off. So if I just quickly compile that and upload this one, beep 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 beep. So now it's changing every quarter of a second. Hi Will, hi Dylan. Bird, 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 bird. Arduino. You've only got one. I have got way too many Arduinos. I haven't done much with them for a while. That's why we're doing a little, like, getting back into it thing today. But I used to have good fun with doing them, but I haven't touched them in that long. Hi Liz! Hi, hi, hi! Used it to flash old 3D print board. Oh, nice. Right, I'm going to move some of them things over here. I want to get this working again. It's a little LCD screen, which just used to show all sorts of things. Gonna be gone for a bit, have fun. Right, stepping by, Panda. Hope you have a good night. Didn't have a bootloader, so I had to inject it through a 6-pin header. Can't remember the name of it. God knows what that one might be called, but still, it was great that you managed to do that. It was great that you managed to do that. I can English. There's just way too much going on at the moment, and just like, you know, words are like secondary. Also, I realise if I put my elbows on the table, this shakes like a hell of a lot. So like, if I need to strangle someone, it's just like, I can give you really the effect of it. Yeah. But anyway, we've done State Road. We have a light that flashes. Now, just to make it go absolutely mental, let's turn that down to 100, which... yeah, it does in their comments say, wait for a second, so 1000 was milliseconds. I just made the assumption because it usually is, but... yeah, on and on and on and on, but also off. Okay, so I guess we'll just leave that going as it is. So what do we have as the next example? Ico gives all of this. Okay. It's explaining through the code. I'm going to be skipping through a lot of the explaining the code in the document. A, because the code is actually the easy part for me. But B, because I'm going to be explaining as I go along, because this is... hey, they actually did the same thing we did. You're now going to make it blank faster, as you might have guessed. This key to this lies in changing the parameter in the delay command. Yeah, that's basically what we did. Now, unfortunately, we've got to find things. Components required. Arduino. Got that. We need a red LED. Do I have a red LED? I should have a red LED, but the problem with a lot of this is basically, is it here or is it somewhere else? I also need some resistors and male-to-male jumper wires. If you're curious what male-to-male is, it's one of these. Basically, they have metal bits shoved out the end. That's a male to female. Outie bit, innie bit. That's basically how a lot of connectors are defined. The male has an outie, the female has an innie. You only use as a flash tool. To be fair, it would make a very good flash tool. First time seeing IRL me. Well, you picked a good day because I decided to go full model. I have the same skirt and same top and the same hoodie. I decided to lose the fishnets because I thought I might get banned. I will be a mature adult. I will be a mature adult. No. Don't be a mature adult. No, 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 no. Also octopus. Octopus NG. Hashtag ad. I've only got it because it's cute. Male-to-male connectors just write so many jokes. I mean, yes. Yes, it does. So does me. And my finger in an octopus butt. Please get it out. No. I know, like, I only kept it wrong because it is so cute. Hey. Okay, so I need to find resistors and LEDs. Wait. When I say I'm looking for a random bit, I'm going, is there any in there? No. We'll actually say there's actually a label for resistor kit in there. Resistor kit is not in there. Random box full of crap. There is quite possibly down the bottom of this box some of them that fell out somewhere loose. I mean, it's one of the modules out of this kit, so I should probably take it. Okay, so where are the resistors? I do have a pack of resistors here. I know I have LEDs here. Where are they? I got a random strip of resistors, but I have no idea what resistors are. Are you labelled? No. Not at all. Unfortunately, that means we need to actually read resistors, which I don't know if anyone actually knows the colour coding. I do not. To be fair, like, it's not easy, and I'm guessing this probably has it listed. There we go. I could sit around and read the resistors and read what the code is. But yeah, are you Ukrainian? Oh, now you made it weird. I make everything weird. Yeah, no Arduino is one of the best flash tools because it's so powerful. As far as its capability goes as a raw chip, unlike the ESP32 requirement of shit. Yeah, but to be fair, I believe, is it an ES2 board on these? I can't read shit. Like, it is very similar to an ES2 board, the actual chip in the middle of it. But it does have the entire development board around it. I can't remember if it actually is, or it's very similar. Okay, I found the right box. This box. That's a load of resistors. And that has all the LEDs. I also have random stuff like... Anyone who's done like Minecraft, Redstone, etc. will know like basic logic circuits. Well, that has 4 NOR circuits on it, not all. I'm not going to get into the whole thing with logic circuits at the moment because it's way beyond what we're doing. But yeah, I have like 4 NAND on a chip. I've got all sorts of stuff in here. I'm being very careful with a lot of this stuff because there's certain ones of these that just like full name and address. Comes in hard. Most of that box can go over there. Most of that stuff is extras. This box has LEDs, it has a couple of chips and capacitors. It has some much bigger capacitors. It has some little buttons. It has some transistors. Shit, I should have made transistor joke today. Right, so it said we want a red LED. So that's what we've got. I will have to say, I know some of these LEDs don't work. So I will have to actually check when it comes to things, because we could hook everything up completely fine and it just doesn't work. So I'll put you down there, I'll put the transistor back in there. We don't need anything else out this box at the moment, so I'm gonna seal you up so I don't knock you everywhere. And then we get on to the fun of trying to find what resistor we want. Because luckily, I left the transistor out. Because luckily, most of the transistors I have do have actually written on them what they are. Right, you need 220, 1000 and 10,000. 0 ohm resistor. This resistor does absolutely nothing. It is there just to be a resistor. Ah! What's up, Bandit? I have no idea what them ones are. Not very helpful. Okay, them ones have very little written on them. 220. So, they're the 220s. A million. Don't quite need a million. Okay, 10,000. 10,000 is one of the ones we want. And the other one we want is not 100k. We want 1k. That's 1,022,000. That's such a good idea because Card Joker's got job. No! And driving his sadness in the shoebox. Also, hello. And what do you mean, you know? I mean, I can just do this and then, like, there's nothing going on in the background. You don't have to see it. The nasty in real life stuff's gone. How you doing, Never? Other than, like, driving is awful. 330. What were them ones? 5 here. 220. 100,000. Come on, I just need 1,000 resistors. Okay, 2,000. Not gonna lie, if I can't find 1,000, I'm just gonna use the 2,000. Right, I'm gonna have to probably have a good look at some of the ones that are unmarked. Because... oh wait. I've got some 1,000s in a pack. Okay, so 10k, 1k, and 220. Right, the rest of the resistors can go back in the box. And hopefully I never have to touch you again. Unfortunately, I'm going to have to touch them again because out of all the components, resistors are the one that is going to come up time and time again. I will actually say I didn't put all of them away. Oh, there's some more 220s. The reason that the 1000s are probably not all there is 1000s are probably the most commonly used out of all of them. It's a 80 mega 32AP. It's a Uno revision 3. Same here, like, yeah, like I said, I wasn't certain on the chip sets, I just know they're quite similar in use cases. But yeah, I was saying before, like, okay, that board I would use for development. This board I would use for actually in practice because it doesn't have quite as many extra components, like extra added ones. But if you actually really wanted to power save, you can lift the chip itself off, use the board for writing the chip, then lift the chip and direct connect to the chip, and that is ridiculously low power compared to any other project. So if you actually wanted to make a battery power project, I might actually put my glasses on so I can actually see shit. You will notice there's paint over them because, yeah, I kind of got a lot of paint over them when I was, well, painting. Bang, bang. Bang. Dun, dun. Okay, so we've got the Arduino, we've got the LED. Yeah. What was double checking there is, I don't know if you can say, I've got this slightly bent. Oh, anyway, one of the pieces of metal coming out is slightly longer than the other. That basically, LED, light emitting diode. But by definition, it is a diode. Diodes only let electricity through one direction, so it's very important to know which way around it goes. Okay, I love this. Component required. The Arduino, the LED, resistor, male-to-male wires. Okay. Component introduction. Breadboard. That wasn't in the required components. LED. The longer wire is positive. The other wire is negative. I will say I am 100% going to mess this up. It doesn't actually matter because it just doesn't work. All it means is you will turn the wire around, so it actually does work, but an LED must have a resistor to limit or choke the amount of current going through it, otherwise it'll burn out. Which is why I have a load of non-working LEDs. Not because it didn't have anything in it, it's because I ran them and they didn't have enough resistance in the circuit. But basically, okay, starting to get a bit more technical here, but V equals IR. Voltage equals current times resistance. If the voltage is preset, which in a lot of cases here is going to be 5 volts off the 5 volt rail, so voltage always equals 5. If you've got basically no resistance on the line, the current, well, if you actually had no resistance, the current would be infinite. It's not going to be that case because everything in the circuit adds a little bit of resistance. Wires basically nothing, but it's not nothing. It does actually get worse depending on like different things, but now you're going into resistivity equations. I did do AS level physics, so I do know some of the stuff there, but I kind of sucked at doing A level, so yeah. But no, the wire does have resistance, so it isn't ever going to technically be infinite, it just gets awfully close. And funnily enough, the hotter it gets, the higher the resistance gets, so... But LEDs are not meant to deal with that, so... resistors resist the flow of electricity, therefore reduce the current. hands talking. Honestly, this is what I say sometimes, like when I'm sitting around and I'm just using the model. I am sitting and I'm just like, I'm doing blah, 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 blah. I was just like, I'm waving at you. Why am I waving at you? You can't see this. I just stopped and waved. Okay, so yeah, this is what I was talking about with. As you can see in the picture, you won't be able to see in the video as much. Unless I can get this to focus in. There's lines on the resistors. From them lines, you can work out exactly what it is. It basically does tell you exactly what each resistor is based on them colour lines. This one is... do I have this the right way around? I have no idea. Well, I'll just go red, black, black. Got 200, so... oh wait. Oh right. Strip the edge. Red, red, black, black. So, first digit is red, so it's 2. Second digit is red, which is also 2, so 2, 2. Third digit is black, which is 0, and the multiplier is black, which is 1. So it's 2, 2, 0 times by 1, which is 220, which is exactly what we want. Also, going off this, it has a brown on the tolerance, so that is 1% tolerance. So it's going to be there within about... so honestly, for all of this stuff, we're going to go... tolerance does not matter in the slightest, to be honest. Okay, so we have a circuit here. My head's in the way ever so slightly in the diagram. So, move me down there a little bit. I might need to make this a bit smaller. So basically we're going to have the 5-volt rail from... okay, you can't see the mouse now. There you go. The 5-volt rail from the Arduino, which is... this one 4 here. That hole is 5-volt. We're going to have that follow along this red line and go through a resistor. The squiggly line, like the back and forth zigzag, is the electronic symbol for a resistor. That with the number written by it, the 220 ohms, is one of these resistors, the 220, which we just confirmed by checking the number. It will continue on from there, through wire, and through the light emitting diode. And then it will go back to the ground wire of the Arduino. So, you know what? Can I do this? Right, I'm just going to use random holes on here. I'm not going for any particular ones. Basically, what I've done there is just put it into 2 different lines on the board. Really, I should be putting these flat, so but for the purposes of today, I'm not going to go to that extent. I'm not even doing this very well anyway, because I'm doing it. Generally, you would cut these down to size and shape. Like, it's effectively the same thing that I've done there, except I've just bent it the very ends rather than... And actually, it doesn't show up on the camera as well that I've done that. Maybe it doesn't actually show up as well. You can sort of see I've done it, but... Make it focus back down here. I think it does actually show up better on the camera if I just leave them raised up. Then it has a lot more of a side profile to look at. Exactly, you can definitely see, given the variety of angles, that it is stuck in them holes and sticking out. Right, so we have these. Actually, I should look for same colour wires, shouldn't I, if I can. Do I have a red male? No, but I have an orange male, so that is going to go into the same line, like same line across as the end of the resistor. Then we want a purple, if we've got that, or the two. You used purple in the middle and black, so you know what, I'm going to use yellow mainly for on-camera contrast out of the colours I've got. So the other end of the resistor gets a yellow wire. Now, as you can remember, can be the positive line is longer. Oh yeah, there's the flat edge as well on the side of. Right, so if I put that in there. Okay, one thing I will actually say that I could be doing for some of these wirings, I don't know if I should or not, because it's going to take a long time. Like, how many? I mean, it wouldn't take that much time to do, it just takes a little bit of time. Is I have this box full of pre-done wires and go, that one's too long. But basically, they're little wires that are made for the breadboard. It was too long, but I just moved the LED across one. I might turn the resistor down to the board so you can see it a bit better top down. So yeah, the 5 volt will come in here, will go along the resistor, down this line and into the red, blue cable, and then up to the red LED. I'm actually going to connect this end into the 5 volt rail. Yep, that is the right one. And then from the other side of the LED, we're going to connect to what I can't read. Okay, one next to. There we go, we have an LED it's not actually, there's nothing to actually do on the Arduino for this one. It is literally taking the power along this wire, across here, across that blue wire, through the LED, and then all the way back into the board. Like if I take out any component of this, like that wire in the middle, it just disconnects the circuit. And I can pop it back in and it works. Yippee! We've learned how to use LEDs. Oh, there's their... Okay, they actually use the side of the board, which, yes, you can do. I just put it directly into the board itself, but what's that? Okay. So, what did they want us to do as a follow-up?
All these dolls together.
Hi, Seraphina.
And all here.
Hi.
All come to see me. Wow.
Can't see much because I'm zoomed right in.
How do I interact all these dolls? All these cute dolls.
Hi. You've joined us when we're trying to work out how the hell a light works. Okay, the problem I'm gonna have now is now I have a loose resistor. And I'm just like, what we making? We're relearning doing electronics, so I've got my Arduino clone out and we're basically doing the basics at the moment. We have just been hooking up an LED. We've also made the board very annoyingly blink every... Well, it's supposed to be blinking 10 times a second. I don't think it's blinking 10 times a second, but it might be. But you put electricity through it and light comes out. Yeah. Well, what we're going to do is this resistor in here. Actually, I should zoom back in, shouldn't I? Enhance. This resistor right here, we're going to replace it, the 220 volt one, with a 120 ohm one with a 1000 ohm one. I don't know how much of that you can see. Well, the light's still on. The light is still on, but it is notably dimmer than it was before. Maybe because they also had me find a 10,000 ohm. So this, when I put it in, is actually going to reduce the current by 10 times using V equals IR. Because the 5 volts is fixed, so it's going to be reducing the current. So I'm going to just pop that into there and that into there. There you go. That one's a lot more obvious on stream. That's running it 10 times less current running through it. Because it's still running through 5 volts of current at 5 volts of voltage. So V equals IR. There's 2 fixed points. I'm going to ignore arguments, all other resistance in the circuit, such as the LED and the wiring itself, and just assume that the resistor is all the resistance on the circuit, because I'm not doing all them calculations. So let's just say before I made that change, the resistor, the circuit, before I made that change, the calculation for the circuit was 5 volts equals I, which is the current, times by 1000 ohms. It's now the same times by 10,000. So basically the current is like gone from a little bit, because 5 equals something times by 1000, or to switch it around, I equals voltage over resistance, which would be 5 volts because we're connected to the 5 volt rail, and divided by 1000. So it's 0.0005 amps. So we're at 5 milliamps. Oh, yeah. If basically we added the other one in, that's 10,000 rather than 1,000, so now it's 5 over 10,000. Why did I start doing maths? my head hurts. I've only just, yeah. But yes, put less electricity through, less light, more electricity, more light, or fire, or explosions, depending on how much more. Did you know you can turn a resistor into a light bulb for a fraction of a second before it explodes? Ask me how I know. Also, ask me why I was banned from doing science lessons for quite a while. I can't remember exactly how long I was banned from doing science lessons, but I do know I was banned from doing them for a while. And when I say bang, I mean it was a very, very big bang. And all that went was the resistor. In a puff of smoke and blinding light. No, to work out the amperage that went through that. Oh god, I would not want to know what amperage went through that. Like, that'll have been quite a bit. Plus, we were talking like much closer to mains voltage. You can also turn a large capacitor into an anti-bully stick too. I mean, yes, you can. I would say actually the best ones for that were the little electrostatic motors out of electrical lighters. They were absolutely brilliant for doing that because, well, it was basically made to be small and build up a charge very, very quickly with as little mechanical motion as possible. So a couple of them linked together actually made for quite a big shot. Anyway, I'm going to have a look at this and go, what did you want us to do? I'm assuming you're saying switch out the LEDs. Oh god, what resistor are you? Red, black, black. So 220 times 1. We were just studying the things on there. Don't worry, I don't know the resistor colours off heart. I was just checking this was the 221. Okay, I'm just going to weave you through the other resistors because unfortunately that resistor would stay loose otherwise, and I would be like, I have no clue. I need some more little baggies like this because that's where my spare 1K resistors are. Right, so what do we have next? And can I actually do it? Because I did say RGB LED. Do I have the 4-pin LED? Because that I'm not actually sure. Okay, I do have the 4-pin LED. That's there as 4 pins. The 830 tie point spreadboard. What? Oh wait, are you the breadboard that it didn't actually put in the list before? No, that's that one. Okay, so what is the tie point spreadboard? Packaging. Oh, is it one of them? Yeah, it's just the breadboard. What? Okay, I'm skipping through this too quick. I can't find anything. Yeah, instructions for Arduino. Blink. We have done. LED. Resistors. Male to male. RGB LED. And okay, I need 3 220 ohm resistors. Also, where are the 1K resistors? I use 1K resistors. I have 10K resistors. I have no idea. No, these are the ones I just hooked through. By the way, it's not flashing 10 times a second, it's 5. You have 200. Yeah. I know what I meant by. But yeah, it is the entire on-off cycle for. Okay, which one is this? Is this the right one, or is that? That says 220. Are your color codes the same? Yes. So are you actually 1000? I can never remember which way is the start and the end of these. Thank you for the stretch. Whoa. Okay. Where's the graphic? Oh, I'm reading them backwards. That's it. Brown, which is 1. Black, so 0, 0, 100. Red, which is multiplied by 100, is 10,000. They're the 10,000s. Okay. I need to literally just write on these scripts what they are, because the amount of times I get them out something and I don't. It's only tiny, but these ones actually have been written on the strip. 220. Can't say it too well there, but I will put the other ones to the side so I don't get them confused. So we have these. We have. Okay, you are a 10,000, so I'm going to put you in with the 10,000s. And I am gonna sort of put things away as we use them. Them wires can stay connected because I assume we're going to use the 5-volt rail again. Right. You can go there. Okay. Breadboard, male to male, RGB LED, and 220 ohm resistors. It has 4 leads. One's for the cathode, and each of the others are for blue, green, and red. Here's the diagram for it. It's basically 4 different LEDs in the same package. Those connect cathode goes to ground. If you connect it the other way, it won't light. Okay, what I'm actually going to do with this though is get there, innies to outies, as they call them, female to male. What I'm going to do is I'm just going to take a strip of 4 of these and slide them over the end of these pins. Because I don't want to bend these ones too much if I don't have to, because I've never had them out, I've never had them bent, and I don't know what I would actually use these for. So I try not to completely bend pins if I don't have to. And using the female to male connectors, I will be able to push them in there. Now each of these wires is connected to a different connector on here. Now I go, which way around again was this? I think orange was the one that goes into ground. Have transistors here. You know, it's funny you should say that, because I actually did realise before, and was like, I should have made transistor joke. Hey look, it's me. Just a little transistor. Just a little. See, that's why I should have it. I should have that as like a hair clip. Just a little transistor. Was thinking about what you said about the code and was like, wait, no. Yeah, like, I thought originally about making 15 milliseconds each, which, to be fair, I don't know how long it takes to actually switch, so probably wouldn't have been 100 milliseconds in total either, but yeah, just never did. Right, so I will actually say I am 100% not looking at the instructions, and I'm just sort of winging it. I'm just going, right, so you're going to be saying to do that. You go in there, you go in there, and okay, we found the red LED, which you can't see. Oh, bum. Yeah, I shouldn't be doing that. I definitely shouldn't be doing that because I don't know if you can see how bright that's going, but that is because I accidentally connected it to the wrong side of the circuit. And because it was connected to the wrong side of the circuit, it was kind of not going through the resistor. That was literally just me not not doing things right. Okay, so I'm gonna stick you under there so that gets jammed here. We've got one connected, so the yellow cable is apparently connected to red. Not long, even most cheap microcontrollers are well into the megahertz range. It's less than, and I suppose the code I am using is just compiled and stuck on the chip, so and that's moved. Okay. We now, would you stay under there? Have red and blue. If I disconnect the yellow, we only have red. I mean, we only have blue. If I disconnect the brown, we have red. Now we can go in between and bump, 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 bump. And we need one more resistor so we can hook up the green.
Those celestial messengers reminding us that even the smallest rock can have a hand at sculpting worlds.
Like I said, I'm not worried about actually putting stuff in the breadboard very well, as long as it's in. Okay. While it's not true, you will actually notice there's a little bit of a blue hue to this. It is very white light. But now we can do all sorts of combinations, like if I take the red out of it, it turns blue. If I take the... what was the second one? Okay, you're red. Oh, that was blue, wasn't it? Yeah, that one's blue. And you're green. Yeah, take the red out. We've got like turquoise, I guess. Yeah, because that's blue and green, so that's going to be like a turquoisey. Take this one out. We have yellowish colour. Don't know how to get that to show up better on camera. Because the camera is picking it up as a very white light. Even then, it's... Am I crazy, or does the white look blue? It does, and that actually is a thing in LEDs. Like, you will actually notice it a lot more in cheap LED lighting. They often have a blue tinge to them. I can't remember the exact reason, but I think... okay, blue LEDs are harder to make anyway. Numerous reasons, but... the thing with it is blue light just transmits a hell of a lot better in a lot of aspects. So you actually need to, in LED lights, turn the blue down a bit. Like a true white light would be every colour equally. But because I think it's efficiency ratios and stuff like that, you've actually got to turn the blue light down substantially to actually get it to be white. Like, let's see if we can do that here. That line was blue. Let's see if we can take... I'm going to knock this right down. The one I'm putting in here is a 10k resistor. So it is about, well, just rounding it and say 40 times stronger.
This stuff makes me nauseous, losing what they taught us. Gotta tread real cautious. But I go back
I can't get it in. Unfortunately, it's a little. Oh. I suppose just take that out, get that in, and then put that back. Yeah, unfortunately, I think that's too much for the white light. Okay, so they were the 10Ks. 100k, so like 4 times 100k. Yeah, 100k is 4 times bigger. No, probably balancing the colours. 2 different LEDs are actually different efficiencies. Yeah, like you would think that when you were making this LED, okay, it's currently yellow, which does not come through on camera at all. And by yellow, I mean the combination of red and green. Okay, that actually is still quite blue, but that is actually our whiter blue than it was before. I've got no easy way to switch. Actually, I do. I don't know how much difference you'll be able to see on camera though. Right, I'm going to put that in that one. I've actually increased the amount of resistance on the blue line alone by 4 times. So there's 4 times less current going into the blue there. This is white light, apparently. But that has a very, very, very blue hinge to it. If I reduce the current going to the blue light by 4 times, it turns into this, which is a lot more neutral light. It probably actually needs to be a tad higher than that and a touch less on the yellow, because I feel like it has to do with the position on the electromagnetic spectrum. The reds are hard, the blues are easy, so you need like less blues and a bit less yellows, or buffed reds. One of the two. But there's a load of things you need to do to get the balance actually on the white. Like this colour here, when I actually put it on stuff and looked at it closely, I would say is slightly greening. That could be the board underneath. That's why I'm trying to get my finger in the way. But it's definitely not blue. Oh damn it, I was gonna have coffee. See? Torn to Doug today. But fine, I will have water. See, I do have water too. You know, it's bugging me now they've pointed out that was the code. I'm going to try and type on this. I'm like, wait, where's the keyboard at? Hmm, 50-50. Sketch, verify and compile, and upload to the board. We'll see some flashing lights. Yeah, that barely picks up on the camera. Like you can see it's going on and off, but it is flashing a little bit too fast for it to pick up reliably. is capturing the after effects of the previous flash. Right, I am going to turn this back up to the blue. Actually, that you can see is very blue on stream even. That still looks a little bit blue, but that just looks very blue. So yeah, you do need to like change them. Also, green has lower efficiency than blue, but our eyes are more sensitive. Sometimes have to turn that down as well. Ah, jeez. That doesn't surprise me. I have no idea what numbers you are, which way around you are. You know what? It's easier just to hold them next to each other and go, you are completely different. So, you are not one of these. So, I'm assuming you're one of these. Someone with blue eyes, yeah, sunlight and bright light's the worst enemy. I mean, I don't think that's how it works, but it might. I don't know. Right. I think before we move on, I'm gonna quickly grab a drink. Because my coffee is going cold. I could just guzzle that. What do we even have coming up next? Oh yeah, we've got the colour chart. Because you do need to remember, like, it is not the same primary colours as paint. It is different between pigments and, you know, light. Primary colours of light are red, green and blue. Which means you have yellow, cyan and purple. I'm trying to think of it as a name for it, but I think it's just purple. Ah, God. Theory, pulse width modulation. It's a technique for controlling power. It's basically, we talked about it before with digital power levels, but power width modulation is, move you across slightly. Basically, if you want it to be on 10% of the time, you only have it on the high power 10% of the time. Or if you want it on 50%, half the time is on, half the time is off. Or 90%, 90% on, 10% off. Basically, all it means is effectively it's flashing very, 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 very quickly. But because of how things actually work with that level of power, like, things don't tend to instantly turn on and instantly turn off. So if you remove power, actually we'll probably notice it with stuff like computers or other electronics. If you turn off the power, everything doesn't immediately turn off. Some of the circuitry still has a bit of charge in it, and pretty much every component has that level of charge. Most of them do not have a lot of it. You're talking like pictoseconds, but when you're talking about the power oscillating on and off, it's doing it so many times a second that it doesn't completely flash. In most cases, I will say.
They know when they're shooting up, but heartbroken people do not.
Kept getting migraines every time we go outside. Told the eye doctor, and she told me to always wear sunglasses when we go outside. I mean, yeah, that works. The difference between additive and subtractive colour. Paints is subtractive. Full sweat. Yeah. Yeah. I don't know what I said, but I might have said power.
Broken. Simply
Yeah.
trust what your mind is telling you.
That's indeed how it works. Eyes absorb more sunlight than people do. Okay. Right. I have no idea where you're going with this, so roughly every 1/500th of a second pulse width modularization will produce a pulse. The length of this pulse is controlled by the analog write function. So analog write 0 will not produce any pulse at all, where write 255 will produce a pulse that lasts all the way until the next pulse is due. So it's actually on all the time. So yeah, this is the pulses every 1/500th of a second. Every 2 milliseconds.
When your
The
heart
pulse can
is
last for up to 2 milliseconds.
what your mind is telling you.
Anything as low as 0.02 milliseconds if you tell it to write 1. Actually, no, because yes, divide by 255. So yeah. I was going 1,000, but no, it's going to be math. But anyway, it's basically that's how you control that. Okay, so we're going to be connecting to D3 power width modularize pulse width modularization, port digital 3, digital 5, and digital 6. And then we're going to be using the program to do this. Okay, so yeah, you've got code available, but void setup is going to be green. Oh. Okay. Oops. I was wondering what pin mode blah 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 output was. They've literally just defined a number that, like, I don't get using a define like that in programming. Like, you're never using that again. You've literally just added a define in that sets a word to a number and stuck it somewhere randomly in the code. So now you have to look at that part of the code to understand what this second part of the code actually means. Whereas you could very easily put, if you needed to put the information at the top of the file, put a comment in to say what the information is. It does not need to be in 2 places. I have no idea what they are, so I don't think I know anything about them. Also, persistence of vision is a thing. The eye takes way longer than that for the excited retina cells to go chill the fuck out mode. True. Yeah, that is definitely a big thing as well. Right. So I suppose I'm going to end up taking this apart and doing whatever it wants me to do. They're basically doing the... Okay. Looking at the document and the defined variables, basically it's going to allow us to set different RGB values. So, I guess that's what we're doing when we're back. Like I said, I'm gonna get a drink. Actually, that's a good idea. Go piss. So yeah, I'll be back in a few minutes and then we'll get to this. So, back in a few minutes. Bye bye.
calling me, calling me. They'll be calling me royalty. They'll be calling me royalty. I don't wanna just get by in life before we die. I wanna live a single time, no chances to revive. Days are slip away sometimes when pressure holds too tight. Only I can make up my mind and override the fight. I've been patient, waiting for an answer, contemplating. Didn't get me any closer to the reason why
I was standing, staying still, never said what I feel. And every time I took the blame, carried all this quiet shame. Cause all the pressure in my chest, I've gotta fight to catch my breath. When every step still feels the same, trying not to break. Where do I go from here? Maybe I'll disappear. If I don't try, I'll never know. I'm waiting on you. Where do I go from here? There will be no more tears. Kill the doubt, feed the fire, hear the voices.
Hello, hello, hello. Ah, I feel much better. Plus, coffee. Okay, so what were we actually doing here? Oh yeah, I need to rewire this, so I think I'll zoom that back in.
Not giving up, it's my turn this time. They took a shot, now I want mine. You fall, I rise, I take the wheel.
Right.
This is how it feels.
Where is the diagram we're going for? Okay, I've got the board completely backwards to what they've got, so the numbers are down here rather than top left. I'm just gonna pull these out one at a time. Okay. Right. Orange was ground, which is one next to the flushing. I'm just turning that so I can see the label on the edge of the board. Okay, so I'll just closely match what they've got, just going across to the other side with each of the resistors. So there's one line. It doesn't actually matter which line I go into on the other side of the board, because although the lines across are connected, they're not connected across the halfway line. So them 5 pins are connected and them 5 are connected, but they're not connected from one side to another. Well, they are now because I'm putting a resistor between them. But okay, this one is actually stuck. Yeah, I've got that jammed. Might need to cut that one, or just leave it and try and get unjammed later. It's connected at least, so that is the main thing. Right, so you want the pin that is next to the orange, which is the red wire, and yellow. Okay, I'm going to do some of this partially backwards, because I'm just going to do the red is that side. Actually, I'll do it on the front pins on these. The red is on the left, like the diagram. The green is the next one on the other side, which is the red wire. And the brown is the one on the end. Okay. Now, the other end, I'm going to need some mil, which, I have some here. I know I do have some here, but where? Right, so the red goes to number 6. So red is that one. Number 6 is that one on the board. If that would actually go in properly. Thank you. Wait, no. 6 is that one. I read where 7 was and I went the wrong way. So green is going to be into there, goes into number 5, and the last one for blue. There's different type kill. Gonna go into that one and into number 3. So we've got all these connected into ground 6, 5, and 3. Connecting to the respective resistors on the board, which connects to the different wires going into the LED, and the LED goes into the ground pin. There. Okay, now it's programming time. Now, what I'm going to do for the program is just load up the example. Oh, that's how I had the zip libraries. Okay. Yeah, they've got a load of examples in here. Not going to look at most of them. Lesson 4 RGB LED. Okay, I'm just gonna find it through the documents. That's gonna be easiest. Board, RGB, LED. Never's. Yep. To be fair, we saw that and it was just like, yeah, that has to be Never's. Don't save. Okay. Basically, oh my god. Why have you got so much code in this? Like, I'm looking through the example code. So that's displaying right, yeah. So, can I? Okay, I can reduce the size of that so I can see everything at once. Define the pins. Blue is in number 3, green is in number 5, red's in number 6. The pin mode for pin 6, because define basically says whenever you find this text in the code, replace it with this text. So it's just saying, instead of me writing 6, I'm going to write red. Find and replace that. So it said that red, green and blue, so 3, 5 and 6 pins are outputs. Write red as a high signal, green as a low signal, blue as a low signal. So the LED will be red when it turns on. We're defining some variables for red, green and blue. And delay time is going to be 10. I don't know what 10 is because it doesn't actually specify it here. Well, it says fading time between colours in the comment, but it doesn't say time frame. So I'm assuming 10 seconds because, yeah. 10 milliseconds would not be quick enough to see. Red 255 is the maximum, green and blue is 0 minimums. Also, this kind of annoys me because they've got no indentation on the loop. I don't know on this IDE. Good. I can select all and indent it. You have an indent auto format. There we go. To be fair, like, it just makes it a little cleaner to look up, because when it was all flat, it was not obvious that this bit in the middle was this loop. Like, if you read the code, you can read bracket to bracket, but having it indented just makes it obvious. Okay, so basically, when this starts, it's going to be full red, no green, no blue. This is unnecessary, so we already turned on red in this setup, or in the previous loop. Regardless, it turns red. Okay. Yep. So basically, this is going to loop through 255 times, or 250. Yeah, it will be 255 because 0. We'll start with I. It will go until it hits 255, which will mean it will run that many times. After each loop, well, before each loop, or after, I can never remember. Like, I would need to actually check that for the before. It's going to be before the loop, isn't it? Yeah. For each loop, add 1. No, I'll have to. It's been a while since I used the for loop in C. You need to be set on Arduino. Anyway, it's going to take 1 from the red and add 1 to the green. And then okay, the delay is actually milliseconds. The delay time as specified here. So basically, every 10 milliseconds, it's going to take away 1 red and add 1 green. So at the end of this, it'll be no red, maximum green. And then it's just setting up to make sure. Then it's going to take away the green and add blue. Then after that, it's going to take away the blue and add red. So every 10 milliseconds, it will take 1 away from a colour and add 1 towards. Yeah, iterate I by 1 from 0 to 254. No, what I was trying to remember is whether or not the I equals I plus 1 is done before the loop or after the loop. I believe it's done before, but I didn't want to say definitively because I can't actually remember. Anyway, let's compile that and upload. And now, from green to red. Wait, that looks green. From green to red. What? Is something not connected right? Yes, that line isn't connected. I didn't have the resistor in properly. Okay. I was looking at that and it was going from green to red and I was going, hang on, you should have a blue in the middle there. Okay, green to blue to red to green, blue to red, and just loop. It didn't think, which is why the iterating with less than 256, they'll also get sets 255 and stops iterating. I suppose it would make sense, but I can never remember that. You know what? We can test. Do you have a God. What's multi-line commenting say? Flash start. Yeah. Okay. We're going to make some very small modifications to this. I suppose while I'm doing this, I should probably zoom out slightly so you can actually still see what's going on. I got all big. Whoops. Yeah, it's an 8-bit integer. Okay, what was I going to do on this? Okay, you're going to want a delay. Let's make it 1,000. Digital right, red, I. Digital right, blue, low. Okay, so every time it's going to set that, we'll do a delay of, I don't know, quarter second. For int I equals 0, I is less than 1, I plus equals 1. Right, what I'm gonna do is add them inside this and switch them around. You know what? It's just easier to do that. Okay, so basically, if it adds before the loop, the end condition will instantly be hit because 0 will turn into a 1, and this code section will never run. If it happens after the loop, a code section will run and the light will turn blue. Easiest way to check this. I've got a semicolon. Okay. Expected. I missed another semicolon. What? Oh, after the delay. Yeah, as you can tell, I've been writing in Python for ages. I haven't touched C that much. Okay. It's going red then blue. So it does, the loop does, it does do it before the loop. I know you can do stuff in C++ like, okay. So generally I wouldn't use plus equals 1 for the 1 increment, I would use plus plus. 1 plus plus explicitly happens after you've used the variable. So you use the variable and then it adds. Whereas if I do plus plus I, it's going to load the variable I, which is 0, it will add 1 to the number, then it will use that. So this should stay at... Okay. That's explicitly telling it to increment it before use. Why are you... So I guess it must explicitly add it to the end of the loop. Okay. Good to know. Like I say, I wasn't sure about that. For anyone who sort of knows programming and not following what I'm doing or trying to work out, you know what? Basically doing a loop and going, does the condition happen at the start or the end? Do stuff. It's // not half. But basically was going, if I need to declare the int before, if I equals 0, if I is greater or equal to 1, then break. Okay, I'm doing pseudocoding. But what I was trying to work out is whether it was doing I plus equals 1 before the conditional, or whether it was doing I plus equals 1 at the end of the loop, because I couldn't remember. Do unsigned integers. A professional programmer, unprofessional programmer, tell you. Yeah. Well, I don't think it would really actually do much here, because I'm pretty sure the limits for this are basically hard-coded as 1 to 255, and unless I want to go and rewrite the driver for doing this, I don't think we'll actually take over 255. Okay. I'm just doing a little check here. Okay. Yeah, I thought so. Okay. So, what we're going to do is do while true. We already have red value, blue value, etc. Red value equals rand 255. We want a random number between 0 and 255 for each of these. Why am I putting in a while true? It's in a loop. Yeah. I'm gonna get rid of their delay time. Yeah, I'm putting it in a loop where it's already in a loop, so that's me being an idiot. Blue value and green value. Right, so we need to do analog right and the values. Tip points, it's 8 bits per bit. What? I don't know. Pulse width. I keep going between power, phase, and pulse. It's pulse width. Okay, so basically, I've got this to pick a random number for each now. We are going to set RGB. We're going to set the red to the red and the blue to the blue, the green to the green. Okay, so what did I put delay in here? I did not. I'll put delay every quarter of a second change. Now hopefully I've actually wrote that right. To be fair, it has been a while since I did C, so I'm not doing too bad. But yeah, every quarter of a second it's changing the colour. I wish there was a way to get this to better show on stream, because this is actually changing colour. Like, you can see it with some of the colours, but you can see it's blinking. It is very definitely changing colours. Wait, run. Where? 2++ run. Like, I thought you had to use modular on it. But say no. Standard library round turns. Metal equals X. See, I'm having a look at that. Blah, blah, blah. That is not the best. You know what? That's going to be the easy way of doing it. Just bring that over here for a minute. Ignore the side bit. Returns random number between that and that. I'm looking at the examples here, and it's if x equals rand or equals x modular range. They've done exactly the same in here. I'm just having a look through, but they've got it listed as, yeah, with no things. It does use the conditional define rand max, but that's just to set the maximum for the my bad, checked it and infran void, so yeah, you have to use module. mixing up languages. Honestly, that is the worst part of doing a lot of these things. It's like, which language is it again? Also, why are you all over the place now? Okay, you just misaligned. I think that's... Yeah, just finishes up. Oh, yay! We managed to mess this up ever so slightly, and just every quarter of a second it does a random colour. Can pick any colour. So we could... What colours do I use? Oh, I can't even remember where my colours are. Okay. Colour picker. I want the colour in RGB, so let's go into here and right. I'm just gonna comment these. That's no comment. Speaking, mixing up languages. Okay, so red is going to be 246. Green is gonna be 213, and blue is going to be 128. I'm just going to change that ordering around so it's RGB. Verifying compile. I forgot to add the semicolons back into them. I somehow don't think that worked properly. There's red value, green value, blue value. That's supposed to be the colour of my hair. That's supposed to be quite yellow. Now do RGB lights. I mean, RGB is pretty easy. It's just all red, none of the others. And then just switch in between. Like, I could do it. In fact, I won't even use the values for these. I'm just gonna comment them out, take these and go. No, I'm gonna get rid of that bit. Yeah, not doing a very good job at reproducing my hair colour. Guess it doesn't like to do yellows that well. Right, so we're gonna do red on, the others off for a quarter of a second. Then we will do swap them around. That's up gone. Verifying compile and upload. RGB. I think the green's the colour that definitely doesn't come through on the camera. I can see the red and I can see the blue, but the green's a bit very bluey. You did the opposite earlier and pissed it off by putting / in the config file instead of hat. Ooh, yeah, it's not going to like that in the slightest. Ooh, now we're going to do some digital inputs. which means I need to find push switches. Which little box of goodies? Do it smooth. Well, that's basically what the program did originally. It just smoothly switched between the colours. Like, I've just been modifying the base program. I can go back and just... all their base program was taking away red and adding green, then taking away a green and adding blue, then taking away a blue and adding red. Yep, that's exactly what the program did originally. Between 0 and 255 or less than 255, red -1, green +1, and then output that, then wait 10 milliseconds and do it again. That's basically where we started with this. Yeah, this is a little switch. I'll put the image up there because it's probably easier to see than the video. But all it is, little push switch. It does have connectors on the bottom for little legs. Little button on top. Oh, you can't hear the clicky. Oh, unfortunately, there's some things are preventing that. So, you need little clicky, you need red LED, you need the 220 ohm resistors and 2 push switches. I will find another push switch out of the little box of goodies. And you very specifically want a red LED, so I will get that. Right. As I'm taking things apart now, I will put that LED back in there. You need the resistors, red LED, and the push switches. So, actually I should refocus this. So I realised I went and got coffee and then I've not drank any yet. Coffee. I've saw a cup that needs cleaning. You can see the nice coffee rim. I swear I cleaned this like 2 days ago. Like a proper clean, not a rinse out clean. I just drink a lot of coffee and it just ends up here. Okay. Wires can come out and go back on the side. All of these are 220 resistors. I'm actually going to leave with... Right. I was going to say I'm going to leave that one as it's stuck, but the other one was stuck as well. But I might manage to get out. Right, we've got everything it requires. That's 220, that is a red LED. We got the breadboard and we got the Arduino. And loads of wires singing randomly around my desk. So, what are we doing with this one? Push switches. Oh, there's only actually 2 connections within the switch. Alright. Makes sense. How do you know which way it is? Okay, it doesn't actually matter. The two connect, both the legs that come out of the same side. One side, well, two sides, don't have any connectors coming out of. The sides that don't have any connectors coming out of are one plane. So the two legs along that edge are connected. Unfortunately, I don't think that actually goes into the breadboard that way, so... But I can just put it across the central channel and we can have clicky. Might use the flattened down wires for this one, because if I need to get in to press the button, you can't hear me playing with the buttons. Actually, can I change that? Microphone, filters. Turn off everything. You can have like random, but it's so satisfying. Have I eaten today? What did I eat today? I had bacon and eggs. That's what I had today. Okay, I'm going to re-put on microphone filters because, yeah, I do not like how it sounds when I've got everything turned off. Okay, so connections for this. Okay, I'm gonna need to move this, shrink this ever so slightly. Even more so. Right, so basically we have it coming from one of the pulse width mod PWM port number 5 going around through a resistor through an LED, and that is going to a switch into another PWM and through another switch into another port. I'm not quite sure what we're hooking up this to do. Use the push buttons with digital inputs to turn the LED on or off. Pressing the button will turn the LED on, pressing the other button will turn it off. Okay, so one of these buttons will turn the light on, the other one will turn it off. Do I need that? Not really. To be fair, it does have the nice diagrams for that, and just going, well, this is exactly how you hook it up, depending on the board and stuff like that. But honestly, I don't particularly need that. I just need to go in number 5 is going into a resistor, which this resistor will do. Resistor into each side of the board. I'm just going to push that down so it's out the way. I will zoom in again. We've got a better view. Actually, I wonder, is that going to be better? Actually, possibly having that light on. I never thought about that before, but having that light on, like my phone light, probably is quite good. make it a little easier to see.
Feel so perfect. I can't even make me lift up from the ground. I believe that we are more. All the world
Right, so where were we? LED. I do know where I've put the other LED from earlier, because that one was pre-bent, which was actually quite useful for the board.
it goes like
Won't actually see it, unfortunately. Do I have a pre-bent? Yes, I do. Might be the one I used before, because I might have just, you know, put it away. The reason the pre-bent is useful is I can just slide into the board. I have no idea if that's the right way around. If it's not the right way around, I will just change it. Right. So, continuing on from the end of the LED, that connects to the ground. So, same line as the LED, and that is going to the ground port in the Arduino. Also, this one thing, it's like, you know how much people say, like, be careful with electronics even when they're plugged in, because you don't want to, and you don't want to. This is currently being plugged in. I have been manhandling the hell out of this. I have touched a lot of different things on here. It actually takes quite a lot to damage electronics. One of the biggest things is actually static charge. Which is why, out of anything, like definitely working with computers and stuff like that, the one thing I would recommend you have is some way of discharging static. Because you're looking at very, very, very high voltages. That basically no amperage, but very high voltage. Okay. Right, continuing with the diagram, you go to one side of one of these switches. So on the same line as the ground in the LED, to one side of one of them switches. The other side of that switch, which would be that line, if I can find a male cable, which isn't bent. You are going to connect up to number 9 on the digital side. Okay. From the same line as the start of this switch, we're going to go to the other switch. So I need one more cable for that. But while I'm on, I should find 2 more cables, because I'm going to need one for that part and one to go to the board itself. So, from the same side of the switch to the other switch, and from the other side of the switch to digital 8. So that one into D8. Okay, that is the circuitry for this done. Don't worry, this is fine, completely fine. Exactly. Honestly, it doesn't take much. Okay, right, what? I guess onto the forward segment now.
Watching this show so long, but it feels like everything that we
Please open the program in the code folder. Okay, I think the easiest for these is just to load their code and just look what they've wrote and go from there. Right, so we can close the RGB one. I do not need serial monitor open. Okay, so it's fairly simple code they've got for this segment. LED pin is 5, button A pin is 9, and button B pin is 8. So, okay, that's the one on the left here is pin A, the one on the right is pin B. White LEDs equals 0. White the type, and it's just saying LEDs equals 0 currently. Okay, so the LED is going to be output mode. The A pin and B pin are going to be inputs. Now the loop is going to be if read the A pin is low, then write the LED pin is high. Basically, the way these buttons work is there will constantly be electricity running through. These buttons work by when you press them down, it disconnects. So all it's basically saying is if you press this button down and it now reads low, i.e. it's disconnected, then turn the LED on. If you press down that button, it turns the LED off. So honestly, this should just work. Except it doesn't, because I'm pretty sure the LED's in the wrong way. Would you look at that? Like I say, I never double checked that, I just went. Okay, so you can press the right hand pin as many times as you want, it stays off. Press the left hand one, and turns on. Off, on, off, on. To be fair, it is very simple presentation of it. All it is doing is, to be honest, you could simplify these circuits somewhat. Some of the things are using it is using the same input and output. Like this blue wire, this brown wire, this yellow wire. This yellow wire goes to ground. Ground is connected to the end of this LED, one side of this switch and one side of this switch. If I take out the stuff for the ground wires, you basically have one connector coming out to here, one connector coming out to here, one connector coming out to here. So it actually does greatly simplify the actual layout. I'm going to just redo that circuit the way I would actually run this, because it looks a hell of a lot cleaner. Because I was doing it more what it was telling me to do rather than got a little blue thing along there. That one I'm just gonna one LED. I swear I get these jammed in the holes so often.
Is it only me? Do you feel I'm sinking?
you're gonna have to go a little bit sideways just because of the hole I put the switch in. And you will go in. Come on. That one. That looks a lot cleaner as far as the wiring goes. Like, it is very apparent that now. You know what? I'm gonna again go away from their circuit diagram and go. That wire goes there, and that wire goes there. Because this is very apparent now that pull that down that way a bit. You've got a wire that comes out to the board for the ground that goes. Ground goes into each of them. Each of the other wires comes to the particular components. And I've got two buttons, one that turns it off, one that turns it on. This is one of the things, like, the first way that I actually hooked this up, it wasn't very apparent how the circuit worked. Hooking it up like this is very, very apparent. Oh, latch. Unfortunately, it's not, because basically this chip along the board is an actual, it's basically a fully programmable chip, and it is actually the memory on that board which is controlling rather than a latch. If I did want to do a latch, I don't know where the actual things for it are. I do have things like NAND chips. Like, all that chip does, it has 4 NAND circuits on it. That one has 4 NOR circuits on it. But I could actually make a latch with some of these. I'm just checking. Yeah, that's another 4 and in a chip. I'm just double checking before I show any of these things, because some of these do have addresses and things on. Do a full adder. I just like, to be honest, I would possibly do that, but I would actually need to do some planning beforehand. It's one of the reasons why I picked just doing from this manual to begin with, because honestly it could be quite hard to on the fly do stuff like this. How do I hide the output window? Yeah, that's basically all this is doing on this one, just going, if you read that the button's pressed, turn the LED on. If you read that the other button's pressed, turn it off. Okay, what I could rewrite this to do is... okay, which one is button... Okay, we are going to get rid of what is A button. So A button is going to go bye-bye. We're going to rewrite this program a bit. Okay. I'm just going to change it to pin rather than A button pin and B button pin. Pin is going to be an input. The loop now is going to be... Okay. We're going to set... I think I'll zoom out a little bit for this. We're going to rewrite this so that we only need the one button. bool, a bool, no, bool, LED on equals, helps if I can spell. Also, you use lowercase booleans. Okay. So we're going to have a boolean, a bool or boolean number, i.e. a boolean number. It's basically a true or false value. It's either true or false. And we're going to use that. Rather than using these, to define it, what we're going to do is we're going to look for the button press. The button press is going to have a different thing depending on the value of LED on. So we're going to do if LED on equals false. Reason for equals is equals will try and set the value of LED on to false. Equals is saying do they equal the same. So if it equals false, then we want to what's the set output? I'm just gonna undo that. Digital write. I could have probably got that from that. If it's currently set to off, set the output to high, and then we'll put LED on equals true. What we will do at the end of this and go, if the LED on was not false, which because there's only one possibility in a true or false situation, it would be true, and we're going to swap these values. So if it was currently on, we're going to turn it off and then set the value to be turned off, and then loop again. Have we got anything else there? I don't think. Hopefully this compiles. No. Oh, did have any expression before? Oh, I left the brackets in. That's copy paste error. Else does not take any variables and will complain if you add that. So, assuming that I haven't completely messed this up, which is a big assumption, when I press this button, yep, okay, I've managed to make it so, oh, right, here's the problem with the one button. Because it does go on and off when I press this button. The problem is, if you hold down the button, it's looping through the code and it doesn't know how long it's been. Right. I know how to solve this, I think. Okay. If the button equals low, after the button do I even need to do the if statement? No. Actually, yes. Okay, if it equals low, then do turn the button on or turn the button off. Then, after you've changed the button, I want you to do a while loop. While the button is still pressed, keep looping. Eventually, I'll let go of the button and the loop gets broken. But the problem that was happening was I was pressing the button and it would finish the loop, and then we'd do the loop again and it would turn the button off, and then it would do the loop again and it would turn the button on, and it was just going through that loop time and time again while I had the button pressed. So depending on how long I had the button pressed, now it doesn't matter. The program just loops. I've got the one button, we're on it off. Yippee! Okay, I did actually double press that time. That time I'm not too sure. But there's probably a better way of doing that, but I'm not sure at the moment. That is basically just a way to prevent it going into the next loop while the button is currently pressed. To allow to use it for a toggle rather than an on-off. Okay, so like it works if I properly pressed in. Okay. Sometimes it's like flashing on and off, but I'm not putting that much pressure onto the switch, and I think I must be pushing into a like it's toggling, but then it's not completely toggling. Like it's just on the edge where it's teetering, and it could go either way. So anyway, we've modified the program, so now we only need one button to do what they did in two. We don't need this one anymore. We have one button that does both on and off, rather than two. And this is basically how it goes with all these things. You start with something that's overly complicated. You need to have one button that turned on and one button that turned off. And then you just go, well actually, if I added this part in here, could I make it so? Yes. Yes you can. So. That's how we improve. Yeah, look how messy their board looks. Look how neat mine looks in comparison. I've got one wire going to each component. In fact, yeah, that wire is going to the ground. I'm just gonna stick it over there. It should be in the other line, but it doesn't actually matter what line it's in, because really that's just saying this entire line is connected. Should probably do it into the right one for, you know, reasons, just so you know what's actually happening, but it doesn't actually matter as long as you don't mess it up. Yeah, mine looks so much neater than theirs. That's why I redesigned it. Oh god. Active buzzer and... Okay, you literally just want me to hook up the buzzer to the Arduino. I don't even know where the buzzer is. Right, I know somewhere around here. I literally just put down a switch. I kinda don't want to move too much until I find it, because I know that's going to be lost forever if I don't find it now. It might be lost forever. Not quite sure where I put that. Oops. Actually, did I put it away? I might put it away. Hopefully I put it away. Right. Bag of goodies. Bag of goodies? Box of goodies. Probably move the keyboard out of the way. That would make things a little bit easier. And zoom out somewhat. What are you? Positional. Okay, what am I looking for? Thing with the washer. You are... rated for decently high power. Okay, that's a server. Microphone? Possibly. Open source, browser. I mean, is that like it looks like it might be? Just I've removed the sticker, or the stickers come off. Remove seal after washing. Well, I don't think I washed it, but... I don't know. I'll have to just try it and see. Okay, you're going to 12 and ground. So I will want the female to male. I'm using purple and blue. I tend to leave these groups like strips together if possible, because then I can go, these two get connected to there, and then the other end, these two get connected. Right, I'm just going to pull you out because I wired that through the keyboard. Right, the board is currently connected to the ground, so I'm going to actually use the board as one of these. Which one? I don't know. Where did you say? 12 and ground. That's 12. And ground is there. I'm just gonna wing this. I'm not even gonna look at the code. I'm just gonna see what happens. Right. So int buzzer equals 12. In mode buzzer is output. Digital. Oh, might need to be analog, right? I'll try digital to begin with. The pin is buzzer, and the output I'm just going to put high. And then after I let go, it's going to get set to low. So I'm actually using the same code as the previous one, but assuming I've got this connected correctly, while I've got the button pressed down, the buzzer will sound. No way! We've just made a buzzer work. No, that one you should be able to hear. But yeah, that's yeah. To be fair, like the buzzer in a lot of ways works very similar to the LED, so rather than just having a light to show things, a buzzer. Okay, so that was a very simple one. Passive buzzer. Okay, so okay, so it's basically the same thing, just using different things. Okay, so we do have tilt ball switch. Okay. I like... Okay, I'll need to move this over. I like the diagram for tilt ball. How can I bring this across? I'm gonna have to do it in OBS, aren't I? Unlock you cross. I like the diagram for tilt ball switch. It's just like, oh, the switch is vaulted over. Doesn't make much sense to do this one. Okay, what I could do is, rather than doing their full thing, if I can find the tilt ball switch, that's going to be an actual thing. I don't know if I've got every single component. The HDX. Okay, that actually, it doesn't have the same markings on it. It has E3DX. I can hear and feel there's a metal ball running in that. What I'm actually going to do, okay, I'm going to remove the buzzer for this because I don't want it continually buzzing at me. So I will replace the switch here with the tilt ball switch. Okay, so the light is turned off. Do not work? Okay. I thought you would trigger. Might need a different reading thing. Okay, I will actually open up the code for this. Where is the code for this? Yeah, it might need a different reading method because some of the different things do. Hey, load up balls. LED. This is not the thing that you have here.
Would you be fine if I leave by the time the sun is out?
Okay, I am going to just change it to the diagram. They say 13. Not their diagram, their code. 13 for that, and 2 is down this end. It's going to be for the switch. In mode is import right high. It's going to high equals digital value. Okay, digital value equals digital read 2. So basically it needs to read the value in a different way than the previous one. Yes. What? No board site. Oh. I forgot I reloaded, so I needed to select what board I was connecting to. An output. Hey, it came on for a second, but I have no idea with that one. It could be just this isn't working. Like the switch itself. Don't think it's directional, but the rest of the circuit definitely is working. Because that was repurposed from the previous one. The LED was definitely working because at the start of the loop it was set to turn to high. I love the inconsistency of their programming. This one needs to be constant, which, to be fair, arguably they all should be constant, but just to show that it should probably still work, I'm just gonna connect that switch back in, and I think despite the read method, despite the read method, this works. It's just that switch is not working. So unfortunately, like, I can tell you it's a ball switch because I can feel the ball going back and forth inside it. It just does not seem to be reading a value. Now we have a light that turns on when you press the button. I just realised it turned the light on the board on when you press that too. Is that explicit in the code or? LED pin. Value. Don't think so. Might be just something the boards do. Ooh, servo motor. Okay. Servos are quite fun things. Servo, a type of geared motor that can only rotate 180 degrees, controlled by sending electrical pulses from the board. These pulses tell the servo what position it should move to. The servo has 3 wires, of which the brown one is the ground wire and should be connected to the ground. The red one is the power wire and should be connected to the 5V port, and the orange one is the signal wire. So, yeah. I'm not gonna. Most of this doesn't really make much of a difference for us now. This is very useful information if you're actually looking to build something from it. Interesting with a lot of these electronics, actually, when you look at the working range, because this is down as a 5-volt thing, it'll actually work between 3.5 and 6 volts. So there's actually quite a lot of leeway with a lot of the different components on just how much power you can put into them and them still work. Right. Okay, I need to go sort something, so I'm just going to put it on like I'm going peeing. And I will be back in a minute. Night, Cameron. Hope you have a good rest of your night. Definitely the favourite bratty Highlander. Thank you.
I've been treading water for some time, picking up the parts of all my life. Didn't get to solve it this time. How am I to break apart? Don't tell me why we can't collide. Nowhere to run, nowhere to hide. Don't you feel it? Don't you feel it? On the break of dawn, I'll follow you to carry on. On the break of dawn,
Got a ticket to nowhere. Come and fly away with me tonight. Can you stay till the morning? Can you tell me that everything's alright? Lose my mind and I'm falling for you. I can't help but be need of us two. Got a ticket to nowhere. When the fighting is over, it goes on and on and on and on, on and on and on. It goes on and on and on and on, on and on and on. In your eyes or your body, you don't have to tell me you don't care. I just need you to hold me. I just need you to show me anything. Lose my mind and I'm falling for you. I can't help but be need of us two. Got a ticket to nowhere. When the fighting is over, it goes on and on and on and on, on and on and on. It goes on and on and on and on, on and on and on. It goes. Oh, so suddenly you're poison the air I breathe. But if you don't hate me, then why would you break me?
Lulu.
Feel in
I was thinking while I was away there and going, we just skip a little bit. Oh god. I kinda want to hook this up. Jeez, that's a lot of me. I mean, that wouldn't be the worst. Okay, the wires basically go. This circuit uses 8 wires into the 8 wires next to each other. I could do that. I could definitely do that. Yeah, I think I could do that. I'm thinking I want to do something good to end off on. So I'm going to need, I'm just going to take things apart and be very careful where I put them, so I know where things are. You are all that type of resistor, so you go there. You need to go into here. But what I'm thinking is, can I hook this up and get that working with this, the display? You need 8, so I'm gonna check what the wiring for the 8 displays. Oh, I could hook that up. Hooking that up would probably be better than playing on with this today. Might leave doing the number pad for next time. Got one of these here. You're all... yeah. Okay. There's a load of male-to-male connectors I will need. You... I just hook you up uploaded female to male. Okay, so where is the 8-digit display? PRL sensor. Come on, somewhere in here. Oh, moisture detector. Sound sensor. RFID. It's pretty cool. LCD display. Oh, did I just do the LCD? Okay, not that one. Okay, photo cell is not going to do much, it's just going to tell me that the light is currently turned on. Okay, I need to find the integrated circuit if I want... Wait, the 8-digit display... What? Don't have an 8-digit... 4-digit 7-segment display. Okay, so I would need to find the integrated circuit that goes along with this, which I assume that's this one. I just got something. I think, yeah, that's a photoresistor. Can't read the lettering on this. The light isn't actually that good for it. That way. Oh, it's two way up. HC 595 does not seem to be that one. Yeah, so I don't think I actually know where the integrated circuit is. So I'd need to find that for using any of them things. Oh, that's a single digit display. Still don't know where the integrated circuit is. No, I would need to find that because that's the only integrated circuit that I can see in here. But the numbering on that does not seem to match. Still. Unless... Yeah, that's very clearly indicated. There's 538. I would have to check, because it is possible that I have a kit that has a very slightly different integrated circuit. So it is possible that it is actually equivalent from just a different integrated circuit. But let's see, it's that one. No, that one's completely different. Now, I had one that was mounted on a board there, and I was just double checking that, so I would need to find that. So rather than doing that, I guess I could do is probably do the LED display one. I believe the LED display has everything included. That it does. Okay, so what we want, this one then, is actually that is get the pins on there. So if I do that now, we want the LED display. I'll actually just swap boards and use that one. We want 1K hot diameter, which we have one here, the display module, breadboard, and a load of jumper wires. Right, what I'm thinking I might do is use male to female. Okay, we need 16, 4, 6, 8, 10, 12, 14, 16. Actually, how many pins is there on here? 4, 6, 8, 12, 14, 16, 18. Okay, so I take it we're not connecting every pin. There's 4 in the middle we don't connect. You know what? This might actually be one that I just use their pin layout. I'm gonna swap this around because there isn't a power strip on this side of the board. Looking at this, there is quite a lot that go like this one goes into one of the power rails, the next pin goes into the other power rail, but there's a few down here that all go into power rails, so it probably makes more sense to do them with the jump wires. For the first one, I'm actually going to follow their diagram for once. Is from the first pin into... I'm going to completely ignore what it actually says for like positive, negative, etc. like on the board, and just do it to whatever location they've got, because it makes it much less likely to make an error to just do it by location rather than by what it possibly should be. Go across one pin. We do that line there, the first line of the power lines. the next pin on the LCD will be from there into the far line of the power lines. Hopefully that's in enough connection. Unfortunately, I don't want to go to the next length of wire because that is a big jump. Right, the next one goes into number 12 on this board. Number 12 is that sort, and it's connecting into this pin. Okay, the next series of them are this pin goes into number 11. And the pin next to it goes into number 10. These ones I can actually do fairly easy without looking at much. That is into there. And the next pin across is into there. I should push them ones that way. Mainly so they're out of the way so you can see what's actually happening here, but they're going to be in the way where boom, I'm back, baby, all time. Well, apparently you managed to disconnect WebSocket by coming back. Right, so what's the next pin? Number 8 misses 1, 2, 3, 4 and goes into the 5th. So 1, 2, 3, 4 missed and into that one, and that one goes into number 8. The next pin on these goes into the close of the power rails. We'll get another brown little cable.
One mistake is all that it takes to break up the trust that we made.
You go straight across into the power rail. Or is that the ground rail? That one's the ground rail. The next one goes into pin number 7. Is the next pin down, I believe? It is. Number 7 goes into RS. Right, now we're starting to get into the weirder ones. We have a pot. Demeter, which is that way. If I remember right, this pot controls the brightness of the screen. Now what? Check that out, put you right at the edge. Come on. Go in the hole. Thank you. Okay, so that's the second off end that's into. We'll need a long-ish, and that's not long enough. Might have to be red. That's why I was saying about I didn't want to go above the brown because reds are quite long. But unfortunately, go out here, it's gonna have to be. I'll put it into the edge so I can bend that one down and out the way. Okay, after the red to the pot, we have 2 pins remaining. They are connecting to the furthest power line and the inner power line, respectively. You are connecting to the far line. The one next to it is connecting to the inner line. Okay, that one's inner line. The 2 connections on this pedometer, it has 2 connections, one on the left, one on the right. These connect to the left hand side is to the outer line, the line closest to me. And the other one is connecting to the inner line. I think that's the wiring for this complete. Or can I get these wires sort of out of the way? Not particularly. I'll put that block there. Yeah, that's going to hold the wires out the way. I'm trying to like move the wires without disconnecting everything. Them wires would all slide under there. If I very expertly get in the end of one of them wires, push them wires in there, and then use that to push into that hole. There we go. It keeps all of the wires trapped out of the way. As long as I didn't pull any wires out there, which I don't believe I did. Just need to make sure that middle wire is firmly secured. I believe it is. That'll be out the way for good. What I do need to do is connect the inner wire, the inner line to the ground port. That one. And where's the 5-volt rail? The side? Yeah, 5-volt rail is... Okay, I can see the 5-volt rail over there. Volt rail goes into that one. We have an LCD screen. And we could also change the contrast. Ooh. Okay. I do not know what the actual example program for this is. LCD screen. Hello world. Hello world. I mean, it makes sense. Your first program's gonna be a hello world. Circuit is a lot of stuff connected to other stuff. Include liquid crystal. Initialize the library with the number of the interface pins. LCD print hello world. Loop, set cursor 0 to 1. Column 0, line 1. Print the number of seconds since reset. Right. How can I get this to show up better? If I turn off the light, it's even worse. Okay, if I move the camera right down, can you see? Oh, it's almost picking it up. Yeah, if I turn the camera off, it's awful. The light off, it's awful.
Fact or fiction, you picked your poison.
Oh, there we go. You can see Hello World, and that is the number of seconds since we restarted the program. Now, what I'm going to do is try and modify this somewhat, because that is the Hello World program. What I want is to use this and see if we can get this working. Can we get this working? I have no idea. I'm going to zoom out somewhat since I zoomed the camera right in. What I want to do is connect this up, which I currently don't know how to do, and get this to write to that display. Which does mean, okay, so 154 is the stuff for that, if I need to go back to it. I do actually know that this has a tutorial for how to do this. However, I'm not going to read it. Where's the contents? DHT11 temperature and humidity sensor, page 91. This is what we're looking for. Okay, you are going to connect into 5 volt on the middle. Okay, which one's the ground? Is ground long? And lots of things. Okay. Yeah, you're looking at that way. Probably hold this up. S. Okay, S goes to 2. Away from S is ground. Okay, so the long pin is the control pin. Like the data pin. Long is data. Actually, I can probably, yep. Number 2, the one they use, is currently free, so I can use that. It's going to take one of these. Go right, you go from there to port 2. So that is in there. The middle port goes to the 5-volt rail. 5-volt is the bar rail as things sit. Actually, I'm going to take that out for a second because it'd just be easier to go put these in without that sitting in there. And then the close rail, or the last one. Oh! Funnily enough, the thing I saw before anything was Tom was just subscribed, and I was like, huh? Thank you, Nardo, for the gift sub to Tom. How are you doing?
Burn down the city, let it into the storm.
Oh god. Right. So we have got this. This is hooked up. I am going to need to check this because I do not know how to read this module. So I'm literally going to check their code for it because I literally have no idea. What was it? DHT11. Open up their example code. Right, you're not going to be able to say this because, yep. Okay, you're doing that. Measure environment. Static bull, measure environment, temperature variability is. Right, static bull, measure environment. It worked. Returns a bull. What?
I'm not broken. Already cried my tears enough for an ocean. I've been in the cold rain on my parade. I'm still on my feet, stand tall like a mountain. I am undefeated.
Where are you getting the temperature and humidity from, though? Huh? What? Oh. Doing good, just go home now. How are you? Oh, I'm not doing too bad, thanks. Oh god. Oh god. I was doing better. Like, okay, you can't see that again. How long are you planning to stream for? Probably not much longer at this point, to be honest. No, thank you for... Oh my god. Thank you for the resub. I don't... Dream Elements, I don't know about that. I mean, I think Stream Elements is confused because Stream Elements has read for 13 months, but it's just like, 13 months, 11 months streak. Stream Elements just like 13 months in a row. I mean, to be fair, absolutely amazing, and thank you so much, but they're completely different. That being said, I do exactly the same when I read their messages. It takes me absolutely ages to figure out what it actually means. Okay, I still don't understand their code for this. Flow temperature, flow humidity. If measure environment equals true, the measure environment is static. Call for a measurement, keeping the state machine alive. Returns true if measurement is available.
Karma's
Okay. Right, okay. Okay. I've got it. I got it now. Right, so does that loop? Okay. I've got it, I understand it now. Like, the thing that was actually getting me with this is, although the code is there, it's calling functions which aren't listed in the code itself, and I'm going, well, how do you work? What do you do? I am just gonna copy paste this code in here because honestly, a lot of this, there's no point in rewriting it, because I would end up writing exactly the same code. So basically, what is happening here is, so I don't know what's happening here, because the board is going kind of crazy. Are you sure? Oh, did you overflow? It might have overflowed. Let's see if I can get this to actually pick up again. No, it does not want to read that screen, like, at all. Oh, if I turn it right down to there, it will read. Yeah, this is what the screen's saying. It's supposed to say hello world. So, yeah. It's just like, okay, what I'm gonna try and do. The DHT non-blocking.h does not exist. Ah. Oh. Oh. Well, that isn't good. Right, downloads, English, libraries, DHT. Library installed. Will it work now? Yay! Okay, we'll upload this again. Okay, now we've got Hello World back. We're learning. Right, I need to add into this code. Right, the float for temperature and the float for humidity. So into the loop, I need to add temperature and humidity in. Also, I just realised now it's went hello world, you can't see that. So I'll change the contrast and now you can again. Right, how do I get it to right to the display? Actually, I know how to get it to right to the display. It's in the code. Right, I'm going to copy this if statement. If measure environment, which is going to call the code from up here. Measure environment, temperature and humidity references to both, or dereferenced to both even. Timestamp measurement equals milliseconds. If milliseconds minus timestamp is less than 3000, it's greater than 3000 UL, so micro. I don't know what L is. Do the sensor measure temperature humidity. If that equals true, then set a new timestamp and return true. So in other words, do that, it works. The reason why it doesn't need to return temperature and humidity is it's dereferenced variables here. When it gets called, I'm calling it using a variable, which is what the ampersand is for. Basically, rather than generally when you call a function, if you pass a value to it, you are passing a copy of the value. What this basically is saying, rather than copying, make a copy of the value, send the actual value, like in memory where that's stored. And that allows it to change it directly. And that's how it's passing the information back and forth. Right, you've got set of number of columns and rows. You've got 16 columns and 2 rows. Okay, I'm just going to do a quick test here. Oh, that's how you do it. Right, okay, I've got it. Right, so we're going to copy this information and put it into here. I'm going to delete the comments because they're not entirely applicable to what I'm putting in here. Set cursor to the start of row 1. And we're going to print temp space. I think this will work, but I don't remember C strings that much. And that's assuming it's actually using C strings. Because I haven't imported. See, I haven't done any imports in this, so it is whatever they've imported for the string function. I assume they'll be using standard string, but it may not be. Because it isn't actually guaranteed this is going to be pure C++. Plus temperature. Humidity. Plus send. Right, I just need to double check with the other code. Yeah, that seems fine. Okay, so I need to, in between the two of them, change the cursor to the second row, which is row 1, because the row starts at 0. So I'm going to verify and compile that. I've missed something out here. Okay, it's using constant characters, so I do need to do some conversion in this. Okay, what I could do is sort of work around this a bit. Right, what I'm going to do is copy that line. And we're going to go, well, that starts on character 0 and writes 5 characters. So 1, 2, 3, 6 characters is the space. So we will start on character 6. Which 0 to 5 is the first 6, 6 is the 7th character. Hey Q, I'm on, I go to the internship, I see electronics, I go to stream, I see electronics, I think electronics ghost is haunting me. Well, the good thing is, you come here to learn like how not to do electronics because, yeah, I have forgotten almost all of it. Plus the other half of it is programming. Also, talking about programming part, I realised I was entering the code below where you could actually see. So yeah, basically all I've done there is split into 2 functions. This is going to write temp, colon, space, and then this is going to skip 6 characters and add temperature. Hopefully, that actually works. If it doesn't, I'm going to need to pass types and things like that, which I really don't want to do, but I could do. Okay. Then message, hello world. Delete the rest of that code. You know what? I might do that, just so you can get the temperature working. Okay, that compiled. Now we upload it to the board. Temperature is 2800 B. Okay. So something isn't right here. You know what? I should just rotate and flip this, shouldn't I? So you can actually see the display properly. Okay, it means my hands are up this end now, but so what is wrong with the code? Wait, I know what's wrong with the code. I didn't blank it. How do you blank this? It's the end of world. The first characters in the line are getting replaced, and then the remaining ones are not. So let's have a look to see how good. Player or flush. Might be flush, thinking about it. So before you add the temperature in, please flush it. So we'll compile that, we will upload that one. Hello world, it's turned on, then okay, so it is the clear, I guess. I thought it might be the flush, but apparently not. No, this one. So we'll try clear. Unfortunately, it doesn't have a description of what the commands actually do, but luckily the ID is telling me that the command exists. So start it again, we've got hello world. There we go. It is 28 degrees, which somewhere I do have another temperature readout. Okay, I've got 27.3 and 50% humidity. Okay, probably not the most accurate. But it's within a degree. I will take within a degree. I do not know what the actual things on this actually are. The tolerances. I just closed the wrong thing. Oh god. Hopefully I'd saved that. Because if I hadn't saved that, then... Okay, I did save it. Phew. Shiny pebble, shiny pebble, shiny pebble.
I got lost tonight under the stars up in the sky. Directions
Okay, so what do we have here? Do. Okay, so that's going to be the next 2 characters. Okay, we'll do the next 4 characters are going to be the temperature in Celsius. So we'll do up to 10 and C. So that's going to make it so from 0, the next 6 characters are going to be 10. Then it's going to have the temperature, which is going to be 2 major characters, point a minor character, and then it's going to have C on the end. Right. I want to copy that, get rid of the clear. Humidity. We're going to change that to be on row 2. You are 5 10 characters. So that, then humidity. Humidity is only going to be 2 characters, so we'll do it 2 characters later and send. Both of them I'm going to change to be the second row. Hopefully, verifying compiles, we upload it to the board, and hopefully this will go hello world. And the first line should say temperature and then humidity. With some zeros on because, yeah. I didn't think about that. Okay, I am actually going to fudge this a bit and just make it so the last line just puts 2 empty spaces at the end. So rather than going rather than putting the percent in, it's going to put percent space, mainly just so it overrides them extra zeros. Because I'm guessing what it had done, it was doing humidity is 50.00%. See, I breathe on it, it goes up then. Oh, it's up 56. There you go. It turns out my mouth has a lot of humidity in it. Who would have guessed? Bum 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 bum. Okay. Oh god. I am looking at this now and going, I could do some stuff with this, but I'm just like, do I want to? That seems like a lot of work. Oh, I kind of want to now though. Okay, now we end the we've done all of the electronic segment. Let's move on to the coding segment of the stream. Yay! Okay, what I'm gonna do is move that up over video capture. On expand, I can, however, move this up. Because we're less about the video now and more about the coding. Oh, you're backwards. Right, can I flip this around somewhat? No, not easily. Right, so I'm probably gonna need to move you up. Okay. This is merely just so I can put my keyboard down so I can actually code a bit more efficiently. Okay, so what we're gonna have the message as is, are you importing anything that does string? That's gonna be the major question here. What I'm gonna do is stick myself massive in the screen because I was doing a comment. Okay, do you have a string? No, you don't. Okay. Okay, so what are we gonna do? How many? It's 16 characters and 2 rows. Okay. So we're gonna do character block message equal. Can I explicitly? Actually, I don't want to declare that as 16. That doesn't actually matter. Message to love you all. Oh. Okay, so basically what we're going to try and get it to do is loop this through the script. Okay, you want to be down here in this block. I just had the comment block slightly wrong first. I might as well move them into the comment block too. Okay, so we've got 2 messages. I want both messages to run on either line. Right, where do I want? How do I want to do this? Okay, do I just hardcode some of these things because it's going to be easier? Yes. Yes. Probably. Okay, so messlen equals 10 okay 5 10 15 20, 25, and 30, 32. 5, 10, 15, 13. What? 15, 13. Yeah, like, no. Then 2 equals 80. 15, 30. What the hell am I on? Right. Int mess 1 equals 0. Int mess 2 equals 0. These also shouldn't be in the loop. I just realised that they shouldn't be in the loop. They should be out of the loop. They want to be declared once and used after. I'm actually just going to put all of that in the comment block so I can just have all this separate.
When your heart is broken, simply
Right,
cannot
so the
trust
loop is
what your
going
mind
to be,
is telling you.
I basically want the text to scroll along the bar. The length is 16.
I need more head pats on each
Easiest way
hand.
of doing this. Thank you for the head parts. I already need the head parts. Copy a selection. Maybe. Oop, thank you for the care package. I do have water. A little zoomed in, but there's water
What
here.
makes heartbreak so difficult to heal. Addicts know they're addicted. They know when they're shooting up. But heartbroken people do not.
Hey, Evil. How you doing? Right. Okay. Let's just start with the absolute basics. Does this work at all? What is 5, 10,
But you do now.
15, 16?
When your heart
Okay,
is broken,
copy this.
you simply cannot trust what your mind is
Go
telling
on.
you.
Test equals. I think that's the right amount. Stick cursor to the start of the first line, and we're going to do LCD print test. And we're just going to say this actually works. So if I do sketch verify and compile, it does not work because I have forgotten to put a semicolon. Joys of working in C.
Feeling your addiction.
What have I forgotten now? Can it be declared with type current? I thought that the types it was using. Also, you didn't seem to have a string class. I can probably import string. I don't know if you'll work with that either. Okay, let's try
When your heart is broken,
stop.
you cannot trust what your mind is telling you.
How do I stop your debugging? I don't want your debugging at the moment. How do I stop it? Because you're preventing me from... Okay. LCD. LCD does have string. Are you a type? Woo! Okay, so if we press F5, that happens. And test. Can be declared with type character. I've literally used your own implementation of string for that. What? LCD, what do you mean LCD doesn't have a type? I'm guessing it means LCD.string doesn't have a type. Doing well, getting ready for bed soon. I hope you've had an amazing night. What? You were not bringing up like any of the things I would expect from that. LCD. You're not bringing up the options for... Okay, I'm just gonna take this back a bit and just go, am I missing something very obvious? I might be. I'm just going to comment out the line down there. Okay, am I forgetting how you declare regular C++ out the string? Okay, what language am I thinking of? I would like to say I have done C++ this decade, but quite possibly not. Okay, so that was 100% my fault. I was using the wrong syntax. Let's try this again. Now we can upload that. Yay, we got thank you for the... Okay, C++ cast string take range. Okay, yeah, but that's for string. I'm gonna have to do this manually, aren't I? Oh god, I'm big again. You know what? I'm just going to see if this works. LCD.player. Text cursor. Print. Message. Message 2. I'm going to make sure I actually save this one. Save as. Not Arduino documents. I want to save it with the other things that I had. You know, it's funny because you can't see the menu. You can see me mouse going different places though. But what? Yeah, I tried to save it then, it was like, no, you can't save it like this. Okay, just verify you already had that compiled. We'll try that. Oh no. Oh no. I don't think it liked it because I tried to do something. Oh wait. No, I know it is. I didn't need the clave in there because it's only going to put the message on once. Yippee! You know, what I'm actually going to do is just... I'm actually going to save that so I can actually do something different with the camera. I did want to have it scrolling originally, but you know, we do what we can. And sometimes what we can is, yeah. Right, Arduino, we do not need you anymore. Boom, boom. I don't think I need my little matrixy corner. I was just like, heck man. Need something to go in the corner, so boom, boom, boom. Actually, I'm gonna very quickly turn the light on slightly. The thing is, I actually have been singing in the dark other than the desk because after I put the light on to the desk, I was like, do I actually need? Huh, it turns out I actually don't. Flip, flip. That way around. Okay, that's left hand. Okay, there's power up. So, what do I do with everyone tonight? Because I don't know. I don't know. Boom, 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 boom. Right. Now where? There we go. You can live up that corner. Yippee, it's me. Well, actually, if I can get out the way here, pull your little still just out of the way slightly.
Standing, staying still. Never said what I feel.
I'll give you a little peek here. Okay, everything's upside down. I'll fix this. Make sure that's covered in a second. Yeah, like all of this shit, all of it. My bed is like literally covered with random shit from preparing for tonight, because I've been looking for, every time I've been looking for a piece of electronics, that's where I've been basically going. And yes, I do have a hole in it. Whee! Now I can dance around and you can't see me and but I'm just being a bit silly. Just a little bit silly. Also, you can see now why I was like, okay, I need safety shorts because I did not trust myself to be able to sit around all stream and not expose anything. That's what label. Funny enough, the label is on the thinnest piece of cotton. I suppose I should just do the rest of the stream for me, because I can't move the camera up, so I can just. There we go, there's no idea. Move that over there. This box can move down here somewhat. And move that one there. Oh no! Oh, I've got it set up at the moment. I'm moving different directions. Okay, so we're missing a bit in the middle here. Hey guys, it's me. You just need to be. But yeah, I can't really turn like this, can I? Because if I start turning, then unfortunately, I can't actually do much like this, because like now I can't actually control anything. I can't be like, I'm gonna raid. Well, I guess I must turn there. Okay, I shouldn't do this because give me legs and it's just too much fun. Now that's when I was turning back. Who was that one I was on? But this has so many holes in it. Easy. Just. I've been trying to not to lose this all night, and I've done a fairly good job. I don't think I actually did lose need the safety shorts in the end, but definitely would think to have them there. Right, now I can actually stand at the computer. There we go. What are they doing? Okay, that seems good. Okay, I am going to send you over to Pamela Hunter. That going. And we've got some raid messages. Hi June. Hi. You've just joined us as we're
I
going
need
to
more
say
head pats
hello.
on each hand.
Thank you for the head pats. They are there, just hidden a little bit. So this week, I don't think anything special
now
is
it's Titty
happening this week.
Wednesdays.
So I think I will just be back on Thursdays normal at 5 PM Eastern, 10 PM BST. Other than that, I don't really know. Don't really have much planned for this week. Essentially, I do. No! I thought no! Everyone's just like, at the end, no. But I need to go because I have got so much shit behind me to clean up because, you know, I've got big boxes of shit that I was finding all the electronics in. That is all over my bed, so I need to get cleaned up a bit. Be sure to copy a raid message, drop in with Hamler. And yeah, thanks for joining me. I hope to see you next time. Maybe with less legs.